Good morning, everybody. Welcome to the stream. Um, yeah, it's been a while since I've streamed. I've been trying out some fluid simulation shorts just to see if I could get a little boost to viewership and subscribers. It definitely works. So hopefully those have been enjoyable and people aren't annoyed by them. But um, I'm gonna ease back into regular content here. But today we're working on setting up the CPU benchmarking scene. We're going to use the fluid simulator inside of Blender, that's part of Blender, to test CPU speed. So I'll probably set up two versions of this file. We'll have a like a light version and a heavy version because some PCs are not going to be able to run a really large scene with a whole lot of detail on it. So we want everyone to be able to benchmark, and then really just having a low RAM use, more single thread test versus a large RAM use heavy scene that's going to use all of your computer more. That's going to be the best way to do it. Otherwise, we could probably use the same scene and just crank up like the resolution so that we have a way to tune it that way. But then it's more a matter of making sure people use the right settings. Otherwise, they're not comparable. So there's a couple ways to do it, but we'll probably go the way of just making a couple versions, and then I'm tempted to test this on my machine off of the stream uh, to get my results on the list because you can see that you know, just running the stream and stuff uses a little bit of the CPU. It's probably not enough to throw the benchmark result very much, if any, because I am GPU encoding for the stream anyway, so that won't matter. But I would, yeah, I just want to make sure the test is reasonable and it's not misleading or anything like that. So yeah, but basically the goal here is just to have a standardized way to test one of the um, more intricate parts of Blender that I've never seen anybody have a standard test for. So, baking on Blender is, well, at least for simulations, is very processor heavy, and everybody talks a lot more about rendering, and that's basically mostly useful for the GPU anymore. There's only a couple use cases to use the CPU for rendering. One is if you have to, and then otherwise just if your scene is so large that it doesn't fit on the VRAM. That's the other time you have to do it. Um, but normally you'd render on GPU, and then all of the math stuff like baking, you would uh, you would have to do on the processor, and most of the time nobody tests the processor. So um, we're going to try to do that, and we're going to try to set it up in a way that's fairly easy to understand. Now, there are other CPU benchmarks out there, but those are more like basically like rendering or gaming benchmarks. Workload wise, that's kind of how they operate. This is going to test the whole system all at once because your system RAM size will be a limiting factor. Your RAM speed will be a factor. And then obviously what CPU and what your cooling is like will change your results for this. Um, so that's the thing we're gonna have to tune this scene a little bit to decide how heavy it should be. I don't think there's any reason to run a 1 hour long test. But if you think about how fast processors advance, we probably don't want it to be just a few seconds or a minute, because pretty soon an 8-core processor is going to destroy any 16 core from today. So um, you kind of want to design your test to be hard enough that it's going to stand the test of time, but also not so hard that like no one can run it. So we're gonna kind of play with it. We're gonna watch our task manager as we do, and maybe I'll pull this to the side. We'll do something like this, and then we'll put task manager up in the side panel, and then we can monitor as we go maybe. MRU Studio says good morning. Hello, welcome to the stream. Glad to have you here. MRU Studios has been doing a lot of fluid simulation stuff lately, and I know he's kind of looking into doing some flip fluids. So it'll be fun to have you here to kind of look at some of the differences between flip fluids and Blender system. The reason I'm using Blender's simulator and not flip fluids is because everybody can run it for free. So I don't want people to have to go buy an add-on to run this testing. So I think that's probably um, going to be the most fair way to do this. And I think flip fluids operates a little differently. So another interesting test would be to try to run the same simulation on the add-on and on Blender system and see if they're different. Um, because I don't, flip fluids, it used to be way faster than Blender simulator, and I don't know if they've updated the simulator in Blender or not. I know it didn't used to use all of your CPU's threads very well, where flip fluids could. So that made a huge difference in baking speed. But I don't know. I don't know what it's like now. So that'll be probably a future test. Maybe not. Maybe not in this one. But if we get time at the end, maybe we'll just try to run the scene with both and see what happens. But yeah. So as far as designing this test, if anybody watching has input or has a specific piece of hardware they want to test in the machine, let me know, because we will be able to design the scene to test everything. Basically, what I mean is we could test CPU speed, but we'll also be testing RAM, storage speed, um, anything like that. So if you can think of a way to better test certain aspects of the computer, let me know. But we'll be watching memory usage, because I also don't want uh, I don't want people to have 128 gigs of system RAM just to be able to run this. So we're going to keep it on the lighter side RAM wise. But yeah, we're just going to basically iterate this thing until it looks like it's a nice, heavy, reasonable scene. And I'm going to target like probably 3 or 4 minutes for the runtime. I think that's probably going to be about where a good test would sit for today's processors. Some of them will do, a lot faster because we are already a couple generations behind. My CPU is the 5950X, which is the 16 core from AMD, but it's already one generation old. So, um, there's plenty of speed boost to be had already on the market. So we want something that's a little slow, but not too slow. So anyway, let's get into it. So I've set up a basic scene here. I need to enable my cube. So and I am not as familiar. Let's call this domain. I'm not as familiar with the fluid simulator in Blender, so I'll be dinking around a little bit more than normal. I'm just not as familiar, but um, here's what I started with. It was what I made the thumbnail from. It's just very basic simulation, but this one runs super fast. It's super quick. No performance issues. So like I think this one even took like it basically baked it in real time. So we're gonna have to come up with something way more heavy than this. But 250 frames of baking to bake in just a few seconds is really good. But I'll show you here. So I'll free the bake, and then we'll just run it again. And it's actually baking right now. So you can see that right about now it's already halfway done. This is very easy to run. Um, it looks like my CPU on the right here, I have it open. CPU is running most of the threads, so that's good to know. But they're very light work on each one of them. And then let's see. So the other thing we need to do is we need to be able to read the scene statistics. MRU Studio says, I'm not sure if you said, but what is the resolution you used for that fluid sim? Uh, so under the fluid domain settings for the physics settings, um, it says the resolution divisions is 32. So I think this goes more by how many subdivisions are in the simulation domain. Flip fluids is I want to say it's a little different, but it's possible it's calling out the same thing. But yeah, in this scene is just a cube emitting fluid inside of a cube. There's no obstacles. There's nothing else yet. So um, that's what we're going to play with today, basically. But we need to be able to um, figure out how long the scene takes. So I'm gonna have to find in here where it tells me how long the bake took. Um, Otherwise, we'll have to manually time it, which is not a huge deal, but it's just an extra step we're gonna have to deal with. Flip Fluids has, and I can pull it up here. Flip Fluids has a baking statistics and scene statistics panel that shows you how long it took to set up the scene that you're working on. Um, but yeah, here's our bounding box. Right here is the size of one voxel. So you can see kind of just that's about what one 3D pixel will be. And then when we play it back here, this got rid of my bake, didn't it? Yep. When we play this back, you'll see that um, the size of the voxels is the same as that little cube. So on the physics properties with the domain selected, I just have this grid display checked on, and that's what showed me that voxel. I think this guy here is actually see, this is our little example cube. So if I stop it here, I think that's what that is. Unless it just scales and hides the domain, but yeah. So the way Blender records it, it is 32 divisions. So I think that's what you're seeing here is there's 32 voxels across each direction. Flip Fluids is a little bit different, so it's that's what I mean. It's harder to compare them because you have to You have to make sure you have the same number of voxels, basically. Otherwise, I don't know how you'd compare them. But let's free this bake, and then so here's my bounding box and my cube. That's very simple scene. That's all there is. Let's go back to solid view, so we're not hogging up resources just by having a render preview on. MRU Studio says, okay, you're not using Flip Fluids. You're using Blender's built-in physics and fluid simulator. Yes. Yes, I'm using the built-in one because it's included with Blender, so nobody has to go buy Flip Fluids to run the test properly. I may make a Flip Fluids one later, but for now, I just want people to be able to download Blender, use it to run a bunch of tests, including rendering, which this won't be for rendering. But yeah, that's the goal, is just to be a standardized test. So I think this one runs so fast. I think we should just let's just double the resolution divisions. So now if I go to the grid display, zoom in here, now you can see this little subdivision cube got way smaller. So let's just go ahead and bake that. Now, as far as making it an interesting test, I think you know, we should put some little objects in there for the fluid to interact with, just for fun, basically. I think that'll add some CPU time and some memory use, but you know, I don't think we need to make any materials. We don't have, you know, we don't need to have any overcomplicated stuff, because at the end of the day, the materials and stuff like that, the scene itself is not going to affect the test. And if anything, it's just going to cause problems where um, people are missing textures or whatever, and then it's just going to be hard to know that we're testing the right things. So I think we'll have very simple, just color materials in Blender, and that'll be it. Okay, so this thing is about half done baking. So I think we're already going to be getting pretty close to a good resolution for a test, and then we'll just add some, um, you know, just add some objects for the fluid to interact with. So this is going to be a relatively simple scene, though, and anybody could test it. I just think we should establish a standard, and you know, anybody could have made a standard scene, really. Uh, but I'll share it on Patreon. I have a link to my Patreon. It's free. You can join as a free member now. That's a new feature they have. So if you go there while this is baking, I'll just show you. If you go to Patreon, you'll see this page. There's this little join for free button on the screen here. If you join it, I think you'll just be able to see when I post stuff sooner. Otherwise, you'll have to just manually check it. But so if you want to do that, you can become a free member, and then when I post benchmark files and stuff, that's where they'll be for now until I get monetized on YouTube. I don't have a way to share files through YouTube. And then I do offer some rendering tiers on Patreon if somebody may have any interest in that. That's also available, but you can join for free. So for now, that's probably plenty. All right. So this got done. We need to find the scene statistics because I think it's in here somewhere. So if somebody knows where that is, let me know, because it'd be nice to just be able to read that right from here instead of timing this ourselves. But if we have to, we have to. You know, it is what it is. So here is our little fluid simulation here. So you can already see there's quite a bit more detail in it. let's see how the playback is. So the playback is worse than the target frame rate, which is 24 frames per second. All right, so it's already choppier, but we double the resolution divisions, which technically, if it's 2 times 2 times 2, then um, it's 8 times higher resolution, not 2 times higher, if that makes sense, or it's 8 times the particles. So I don't see anything in here that actually tells us how long the scene took. So it's possible that we're gonna have to time this ourselves, which is okay, but we just have to go get the um, just have to get a clock app available. Which is obviously not ideal, but you know, it is what it is, I guess. Maybe maybe somewhere in the logs it tells you how long it took, but um, I can show you guys what Flip Fluids shows you. But the other thing we'll do is to get the file size of the bake file. I'll just come in here and select all of these folders. So Blender makes these folders for the um, fluid simulation. So if I select all of them and go to properties, it's going to show us the total file size. So just for this simple one, we have 1.56 gigabytes of um, baking files, and that's including all of these different folders. Some of them are empty. Noise and um, particles are empty because we don't have any of that going on. But I think meshes are one of our big ones. Yeah, it's 400 megabytes. Uh, Data is probably another big one. Yeah, 1.15 gigabytes. So uh, when we report these, we'll be able to report a time that it took to run, and then we'll be able to report a um, basically a baking file size, and it's just going to be all these folders that are automatically created. And then you can see here, what's really nice for sharing this file is that this Blender file is still not very big. So when you bake fluid simulations, they come into these folders here, but they don't save in the scene unless you import them as like an Alembic or an animated mesh. So um, this is less than 1 megabyte actually. So especially with having simple materials that are inside of Blender already, this is going to be super easy to share. Nobody's going to have a problem downloading this. So um, that's awesome. That's what we want. That's kind of the goal here, is to make it easy to share. But yeah, all of the file size comes from when you bake. It generates these additional folders. So um, it's going to be nice and easy to share, and then hopefully the right amount of heavy to run, if you will. So let's um, let's reset this bake one more time, and let's just run it. And I see a few people joined. If you know how to find logs for Blender's fluid simulation, let me know. We want an easier way to record how long this test takes. Um, you know, because right now I have to manually start a timer, which it is what it is. People can do that. It's not that hard. In Windows, there's a clock app. If you're on, I think any other OS, there's a timer in there, I'm sure. So I think that honestly, the biggest problem is going to be just getting from starting the bake to starting the timer is going to induce some error. So, but let's just rerun this and just get a general idea of how long it takes. So I'll hit bake and then start this timer. And I'm just going by my timeline down here. I'm honestly wondering if it's almost easier to do this just like with your cell phone. Um, but yeah, somewhere on here, Blender should give us a fluid simulation information panel. But I'll move this clock over here so we can watch it. So right now you can see Task Manager is only claiming to use like 40% of my CPU, 40 to 50. Um, MRU Studio says if you open the console window in Blender, will it output some of the log information you're looking for? Possibly. That's what I'll have to do. I'll go look at that in just a second once this finishes up. Because yeah, that would really just bake file sizes and time to bake would be the two things that we really want to get. But you know, if this is going to be a 2, 3, 4 minute test, it's not going to be that much error to start a clock separately. So it's just kind of inconvenient, but um, you know, Blender's Fluid Simulator isn't set up just to be a benchmark or anything, so there's no automatic timer. But yeah, you guys can see as this is running, you can see on my screen, um, most of the threads are being used. They're just not. They're just not like very hard. They're not being used very hard. So maybe 30 or 40% on most of them, and then there's a few big ones. That actually looks very similar to Flip Fluids. Okay, I'm gonna have to stop this. Okay, so 2 minutes and 4 seconds. So it takes a 16 core processor about 2 minutes to do this. I would say this is probably still too lightweight because the memory usage is not even that bad. So even with 16 gigs of RAM, you could run this scene easily. But I think my PC was using like 10.6 before I started this. So even with Blender closed and just Windows running, I have 10.6 gigs of RAM used, and it's I don't know why I just have background stuff going. I'm sure, but yeah, but 2 minutes is a little bit fast, I think, because like I said, here in the future, 8 core processors are going to destroy my 16 core 5950X. So we want to future proof the test a little. Um, the way I imagine it is like Cinebench or something where they update the tests every couple of years. Maybe we can push that off a long way so that this test is good for a while. But yeah, but MRU Studio said to open the console window in Blender and try to see if there's some log information. I have to remember where to do that. Let's see. Actually, let's open it up here. Let's just go see because maybe it'll say. All right. Let's see. I assume you're meaning the Python console, right? Properties, spreadsheet. Hmm. Yeah, I think so. So if you run this in Flip Fluids, it gives you just one of these drop down menus has scene statistics. So that's kind of what we would be looking for in general. But maybe maybe the mesh has the statistics. We should go look at that. I don't see them yet. But basically, what we've done is I just have a cube emitting fluid inside of a cube. I just set the cube object to a liquid inflow, and that's it. I haven't changed any other settings. I think, except for just this surface emission one, I just set it up a little just so it has some property. MRU Studio says window toggle system console. Ah, here we go. Thank you. Awesome. Yeah, let's go see. It'll display debug and additional text output based on what Blender is doing. Awesome. Yeah. So let's pull that up and then let's try to bake this again just to see. Because maybe it'll show us some more information in real time too. So I'm currently baking it. Utopia Okay, so it's talking about what add-ons are loaded in, which I think are the ones I have plugged into the user interface basically. Because it says RetopoFlow on here. And that one comes up to the top of the viewport up here, so that's probably why it's talking about that. All right, yeah, I don't see any information in here, which is okay because we can do it just by getting our file size from the file browser and then just timing it manually. So that shouldn't be a problem. But we'll let this thing finish again one more time. Let's watch our performance here. So these are the threads. This is just Windows Task Manager. All of the threads are being used, but they're not necessarily being used very hard. Some of them are well under 50% usage, and you can see the total listed here is about 40% on average. The CPU is running at a lower clock speed, so I think we're getting our, we're getting a multi-core clock, but I think this is way lower than what I normally get. Normally I'm at least at 4.55-ish in multi-core. So I think what you're seeing is a lot of data loading in and out really fast to run this benchmark, but you're not seeing the cores being utilized properly. So all these little spikes and dips, I think it's just loading. It's just loading and unloading the frames. Oh, that looked promising. This little box popped up and I clicked on it, but it doesn't have any information. I think this might be our time though. So when the simulation got done, a little box pops up on the screen. I just clicked on it, and then it gives us a time. So you can use that, or you can manually time it, I guess. So if I just do, let's just do 25 frames again, just so I can show you this. So it'll bake, and then right here at the bottom it says fluid bake all complete. It gives us a time in seconds. So I guess we can use that. We can use that to read our time. That's probably way more accurate than hand timing it. So I'm gonna go ahead and get rid of this for now. You just have to pay attention, unless you know where that information goes, and you would think it would go into the log file, but that's okay. So, all right, I think what we should do is add a couple of objects in here just to have the water interact with. So let's just add some primitives. Let's just add maybe a sphere. And they don't have to be entirely inside of the bounding box either. So we can just have them wherever. Let's add, I don't know, a cylinder. Why not? It doesn't really matter, is the thing. But we're just going to move these so that there's something else happening in the scene. Collisions are one thing that definitely do hog up a lot of resources. So I think it's probably important to have those in the scene. And then we'll shade them smooth just for fun. And then let's give them some materials. So here's what the viewport looks like. Let's just give them random materials basically. Make a red sphere. Cylinder can be what's a good color combo? Green, doesn't really matter. This one up here is what emits our fluid, so that one isn't actually going to appear in the scene, or it shouldn't. Once we bake it, that should disappear. So we don't care too much about that one. Now let's run just a couple frames so we can see what this thing looks like. So yeah, I mean this can be pretty simple. We do need to remember to let's turn on the fluid, and we'll call this a an effector. And we'll add our little cylinder back there. We'll call that an effector. And their collision type. So those should work. I don't think you have to add physics collisions to these, but we'll check here in a minute. So if I come back here, let's just bake a small sample of this again so we don't have to wait for it. And we'll see if the fluid interacts with those or not. Whoa. Okay. Looks like it is not interacting with it, probably. So we may have to add collisions to these. I'm just not as familiar with Blender Simulator, so Flip Fluids handles that for you. But let's go ahead and clear this one more time, and then we'll set this up to like 75 frames to see. And so if you're watching because you want this little test scene, you're not going to have to do any of this. You're just going to hit bake and record the time. So it's going to be fairly user friendly, other than having to just know where the timer is. But you know, you're not going to have to actually set the scene up anymore. And that's the nice thing about this compared to rendering. This you just hit go. You know, rendering, there's some extra conditions you have to check to make sure you're doing it the same. But all right, yeah, see down here it says 36 seconds. So it just says fluid bake, all complete, 36.16 seconds, I believe is that readout there. Oh, okay. I think it is working. See, it's blocked out. It's blocked out around this sphere here. So I think it's just maybe going under the cylinder at the moment. So once it fills enough, it's going to start to hit the cylinder. Yeah, and there you can see it's landed on top of it. So that looks like it's pretty nice. Okay. And then once you get past your frame range, the domain and the primitives click back on in viewport because they're no longer included in the simulation. So if I scroll past 75, you can see now everything goes back to what it was. So this should easily take a little bit of extra time. I don't know if it's enough to be a problem or not. Basically, what I want to do is I want to use my 16 cores as a baseline, and then so if you have an 8 core, you're gonna already probably be multi-threaded um, here soon. If you have 32 cores like a Threadripper, you're probably not fully utilized yet. So it really depends on how your system uses it, um, and that's part of what we have to decide. But let's uh let's free this. Freeing the bake means just to reset it. Let's go back up to 250 frames. And then I know one thing we can do is just add whitewater effects, or what Blender calls them in here is just particles. Because when we add those, it's going to take a lot of extra CPU processing too. So maybe let's just add bubbles. Um, and let's just see how heavy this is for now. So I'm going to go back to solid view because we don't want to be hogging up the CPU with rendering in the viewport. And then so basically what we've got is we have doubled the resolution divisions, and we have added bubbles without any other mods, and then we just have the two um, effectors inside of the scene, and then I believe this plane is also an effector. Yeah, see, it's added down here. So let's run this, and then we'll watch for the timer inside of Blender to see how long it takes. I imagine it's going to take a little extra time, but we will see. All right, so I'm also going to keep an eye on memory usage because I'd like to keep this under 16 gigs of system RAM. It may or may not be possible, but I also have a lot of background processes that I could close if I had to. So there is that, but let's give Task Manager just a little more room. Yeah, looks like Blender didn't like that we resized it while it was baking. I don't think it crashed. It's still running the timeline down there. But yeah, so here you can see we're still running into the same problem where we're not getting full utilization, although the clock speed is coming up a little more. So I think what that means is it's spending enough time on each frame, on each core, that it's actually registering as being used fully for an amount of time. So ideally, what we want to see is um, 90+% utilization at the multi-core speed I normally get, which is about 4.54 gigahertz. And then we'll know that it's fully utilizing 16-core 32-thread processor. So basically, where it's gonna vary a lot based on people's machines, because um, if you have 8 cores, 16 threads, which is fairly standard processor now, you're gonna have a lot closer to 100% utilization, unless this simulator is just so inefficient that it can only use 4 threads fully, which is what this one. Well, I guess it's using 5. It looks like um, it's only using about 5 threads fully, and the rest are um, just doing little bits. So I think the only way to force this to take longer is to increase the resolution. But yeah, see, we're already past 16 gigs of RAM used, so I don't think we're going to be able to get away with using less than 16 if we're going to actually fully test 16 threads here. So what I'm wondering is, because it's just a little past halfway done, so this is actually going to be fairly heavy already. What I think we should do instead of this is maybe cut the timeline in half. So maybe we'll do like 125 frames and we'll bump the resolution up a lot more. Maybe add more like bubbles or something. Um, and then we'll pare it all down and make it back into a lighter scene. So we'll have a light test and a heavy test. That'll probably be the best way to go. And then yeah, obviously like when you guys are testing this, if you when you report your results, it's probably best to list what type or not type, what speed of RAM you have and how much you have. And then obviously what your processor model is, and then if you want to give some cooling data, you can, but I think that's going to probably be hard to keep a control of. But um, if you use hardware info or something to monitor, it'd be interesting to see how hard this really pushes the computer. Yeah, see, we still have quite a few frames to go. It's starting to bog down now. So I think what you're seeing is there's enough detail on the mesh finally that it's starting to use all of the threads more fully. So the threads, the usage graphs on the threads, they're gonna bounce up and down no matter what, because um, the simulator has to load. Each thread gets basically so many of the voxels, and uh, once it calculates the information for that frame, it dumps it back to the bake file, and then it has to load a new one. So you see this in and out. It's loading, then it's waiting, then it's loading, then it's waiting. Um, that's why the graphs look like this. So where you will see this effect go away is where the voxels are so complex that it's going to take the CPU cores a few seconds to run a batch of data, and that's what I'm trying to get to, because I think that's a good test of actual full bore performance. But we also don't need it to be like arbitrarily long time wise. So we have 50 frames left still. It's at 200 out of 250. This one's going to be a few minutes. So I don't know that that's worthwhile. We're going to cut the frames down and increase resolution. Because I'd like to see these threads at 100% utilized. I think what that'll do is it'll push smaller processors into full utilization all the time, and then bigger ones, you'll really see the benefit of having more threads than this or faster threads than this. So like the 7950X, I think is going to be a great one here, or any of the newer i9s that have come out. I think are going to just smash this. But I don't want to make it too light on those ones either, because then we'd just be back to you know changing up the file, which is fine. All right. Yeah, see, it's starting to run a lot slower now. And you can see that the utilization now it's going from probably 15% up to 60% on each one of these threads. So it's actually using them a lot harder. It's just they're not taking very long to process still. So unlike rendering, this data is it's in line, if you will. So each little piece of data that these threads have to calculate is based on the previous data. So it can't just like rendering it just gets so many pixels per thread and then it just goes. So your usage will be a lot fuller. For this type of work, it has to load a lot for every frame. So it's really hard to nail down how much that affects the test. But like a good example of what I mean is if like my memory speed is 3600 megahertz. Um, being that this is a DDR4 system, there is, less bandwidth on this than there would be on a brand new system with, an AM5 platform and a DDR5 RAM spec. So RAM speed might affect this more than I expect it to, because the in and out loading of every single frame over and over is probably significant on this test, whereas in rendering it's a very small percentage of the work. And then on the same note, uh, here's where my file's stored. It doesn't take a long time to load, but I mean you can see that the read and write speeds are jumping. Actually, the write speeds, they're not considerable for an SSD, but a few hundred megabytes per second is what it's peaking at. So um, technically, storage speed could also be a factor in how well your CPU runs this test. But we're still only seeing like 40 or 50% utilization. So I'm gonna bump this resolution and we'll decrease the frames. So this thing's about done. Just a couple frames left. I'm gonna watch for that little pop-up box down here in Blender that tells us how long the scene took. Okay, so we got just one more. 591 seconds, basically, is what it took. So, and that was just on the little pop-up at the bottom. So it took a long time, almost 10 minutes. Let's we don't need it to be a 10-minute test. I'd rather have it push the processor harder than be that long. So I'll free up the test, and I should have checked the bake file, but when I hit free, you see it deleted those folders that we were looking at file size with earlier. So let's let's just see what happens if we double this resolution divisions another time, and then we're gonna make our timeline quite a bit shorter. And actually, maybe let's just maybe do 100 frames. It doesn't necessarily matter, but again, we'll just try it and see what it does. There, so we'll bake 100 frames, and let's just start this and see what it starts to look like. So the first frames don't take very long because the fluid is just falling. Basically, there's no interaction. There's not very much of it, and then it should slow down pretty fast once it starts to hit the um, effectors. And let's see what our usage is doing. Yeah, so now I would say that our utilization is a lot closer to 50% on average. It may be higher than that even. But I'm hoping that once the fluid gets to the bottom of the bounding box, basically, all of these threads are probably going to run higher. But if I can't get these graphs to look like the threads are being utilized fully, it's just possible that Blender's simulator can't fully utilize threads just because of how it works, and this isn't overly complicated. So, um, if all the tests are gonna look like this, where you only get these little spikes that are above 50% on each thread, then maybe we'll just call it good with that. Because at the end of the day, if that's just how it runs, that's just how it runs, and that's okay. So I just need to make sure that there's nothing I'm leaving out before we start to share this. So basically, the way I see it, there's two things you could test with this. You could test single core speed or multi core speed, and not both at the same time. So um, your single core speed is going to be like these few threads up here that are being used fully. If we have a very very simple simulation that only gets a few threads filled, um, but the processor runs at full speed on those few threads, that's going to be an indicator of your single core speed. If you ideally to test multi core, we'd want every single one of these threads to be at near 100%. I'm just thinking that we probably won't get there because it looks like this simulator can't really run the CPU that efficiently, which is also fine. Um, I would say this is kind of like a mixed test because my CPU is definitely being able to run higher speed right now if uh, if the threads are not fully utilized all the time. But you can kind of see the graphs all look the same for all these other threads that aren't the five big ones. So the processor is being used all at once in bursts, and then it gets just a second to load, and then it starts up again. So if that's the case, it's probably just not working hard enough for long enough to register the higher processor speed, basically. So depends on how you look at it, but theoretically, if this is just how the simulator works, then a nice long 100 frame test is going to just really be a good indicator of more or less mixed CPU speed. So what I'm thinking is these fast cores up here are probably running all of the loading. So they're running the in and out of uh, the rest of the threads, because it's got to load and prepare to do the work and then do the work and then it's got to save the work. So all of that is probably being done on these faster cores. And the rest of them are actually doing just the raw calculations for the frames. So, a newer processor, that loading is going to be way faster because the memory is faster and the CPUs are way, 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 way faster on single thread. Like the clock speed's higher, but also the amount of work they do per clock is much higher now too. And that's across the board. That's um, Intel and AMD and whatever else you can possibly use. Um, Mac could be the same. Every generation they improve the IPC of the processor, which is like the basically the efficiency of the cores. So I would imagine that this test will run a lot better on a new processor because the loading is just going to be decreased. So every one of these little valleys in these charts is going to be shorter. Yeah, this is really chugging along now. Um, CPU still isn't showing up at a high utilization ratio. I'm starting to think it's just not going to, which is okay. Um, because it's easily taking multiple seconds per frame to bake now. And we're at almost 32 gigs worth of memory usage. I mean, we're at about 28 and a half, but once this mesh gets more complex, this is probably going to jump up. Yeah, and you can actually kind of see we're still on frame 60. This little dip in the RAM use here, you can kind of relate this memory usage to while it's running a frame. So it's got these little spikes when it switches to the next frame. Interestingly. Huh. But yeah, so just a bit under 30 gigabytes of system RAM used. We're still only able to get about 50% utilization out of the processor, quote unquote. That's not really true per se, but I think it's just showing us that there's a lot of loading time. I don't think that's going to improve at all, honestly. So I think um, we'll probably be good to go with this scene here soon. What I was hoping is to see if once we get a whole bunch of fluid on the scene, maybe we'll get more CPU use, and then if that's the case, we'll start with a bunch of fluid at the bottom of the frame, um, and then we'll just drop extra fluid on top of it. That would start us off with a more complex simulation. Edgar the Face is here. Hello, Edgar. Nice to have you here. We are waiting for this little simulation to bake here, and trying to make some conclusions about what this test is really doing. But yeah, I think Blender's fluid test just can't fully utilize CPU threads all of the time, which is fine. I'm really curious now to pay more attention when I run a Flip Fluids version of this because um, I know one thing that Flip Fluids advertises is they can use your processor more, but but yeah, you can. I mean, you can see the chart on the screen. Um, Most of the threads are only up to about 50% utilized, and it loads in and saves and loads in and saves a lot. So um, I don't know that Flip Fluids can do any better because of the nature of the work. So it's possible Blender has sped up enough to catch them. But to be fair as well, this scene is also fairly massive because the resolution is set so high. So I think um, I can't move the viewport right now because it's locked for baking. Um, but I'll show you the settings. But I think we went up from 32 to 128 subdivisions on the simulation, which means in each direction it has 128 divisions, and so it's 4 times 4 times 4 times the size in number of voxels. So what 64? It's 64 times more detail on the mesh than the basic one. This will be a test scene. Yes, Edgar says, "Will this be a test scene?" Yes, this is going to be a CPU benchmarking scene, and I'm using Blender's built-in simulator instead of the Flip Fluids add-on, so that nobody has to go buy an add-on just to test. And then I will share whatever scene we come up with. I'll share a high stress version, which will probably be this one, and then a low stress version, which will just probably just have less resolution. Um, and then people can test both scenes and just compare, you know, performance. But that way, if somebody has a lower spec machine, they can still run it. And if some guy has a Threadripper out there with 64 cores, he'd be more interested in the high stress one. So, and even this one, um, we're easily jumping to above 32 gigs of system RAM use. So, like this one, I'm going to be wary about sharing because a lot of people have 32 gigs, but probably most people don't have more than that. But yes, Edgar and whoever else is watching, I will, for now, I'll share these scenes, these blend files. The Blender files actually will be very small. Um, because the baking is done on your end, it's not done inside of the file, so it won't be sent with the file. Um, Basically, it's just going to be a scene with simple materials and a couple objects. Um, but I will share them on Patreon, and I have a link to my Patreon, but I don't have a good place to share files for free yet. YouTube will let me once I get monetized. I think there will be a way to share files through YouTube, but um, for now, people just will have to go get it off of Patreon, which isn't a big deal. You don't have to be a paid member there to get files. So, um, yeah, and there's probably other ways to share it as well, but for now, that's how we'll do it. Oh, okay. This thing is definitely taking a lot longer. Um, it looks like average use is over 50% now, but not by a lot more. So I think that's just it is what it is. I think you're just going to have um, some inefficiency of loading, and this is where newer systems with really fast RAM are going to benefit. Because if your storage, your RAM, and your CPU are all faster than this, you're gonna save significant time compared to my system. Like there's no minimum amount of loading time. I think the loading time goes away if your RAM is super fast. So this is at 90%, 91%. It's taken a while. I don't want to stop it, but every frame is more complex. So, and this is going to be an absolutely horrendously massive file for the bake file. So, um, your computer can create data way, way, way faster than uh, any internet speed can download. So, I'll show you in a second how big this bake file is. Um, but normally, when they take this long, the files are just awful. So, the other problem, well, yeah, I guess the other problem with this is if people try to test this, it's going to fill up storage if we're not careful, and that's also silly, so we don't want to do that. 95% done. So the last version of this, we had more frames, way less resolution, um, but it took just under 10 minutes. We'll see what this one takes. Yeah, these last few frames are just brutal. But I don't think our clock speed um, is a whole lot different than like the first part of this simulation. So I think we're gonna maybe just cut this off at only so many frames, or we can back off the resolution maybe. But a 10-minute test is probably a bit too heavy. I just don't. I don't think that. I don't think the complexity of this is actually changing how it's being run very much. So we'll back it off a little. But this thing's almost done, so I'm going to watch for that timer to pop up at the bottom of the Blender page. Okay, now it's loading. Looks like it's getting done. 950 seconds it took. So that is considerably longer than the other one. Yep, the viewport is down to about 3 frames per second. But we'll play it through here and we'll find kind of a interesting frame that looks good, but I did enable some bubbles on this one. I don't know if we can see them though, which is fine because really they just add extra computation. But here's what our mesh looks like. So if I zoom out at all, you can't really see the divisions on it. Yeah, very small divisions. Um, this definitely took a long time. I don't think that we need to have the test take that long. But now I'm in the destination folder for these. So these folders here are the bake files, if you will, that Blender creates. So let's look at properties for these. And 42 gigabytes was generated by this simulation. So Edgar says, "Can you make a variant that works with 16 gigs?" Yes, that is. So the goal is to make a light version, and I think 16 gigs is a good target for that one. To be under 16 gigs, and then the other version is going to be probably 32 plus because that's what this one required. And even just sitting in the viewport, it's about 28. Oh, that's interesting. This is the console in Blender. It looks like it's giving us a total particles count, maybe. Huh. Let's see. I always have to highlight three at a time. Yeah, it looks like 272 million particles is what it's saying on there. Pretty cool. Um, okay, but let's go back to Blender. So let's just think about the packaging. So the scene is really simple. We have basic materials. We don't. That was one thing, Edgar, that we talked about on here is um, not having complicated materials so that there's no problems with people getting the scene, and having to run shaders. So they're just basic, like basically add material and then change the color inside of Blender. So that's all they are. Um, Hopefully this doesn't crash out. But I'll let that run for a minute. Um, but yeah, so the Blender file for this test, even this big one, is only about a megabyte. So all of the data and the space requirements for storage that you'll have to deal with is from after baking. So it's nice because I can share the files to everybody. They're not going to take up a lot of space. They're going to be easy to download. And then you'll have to figure out how to um, deal with the frames, I guess, on your own. But all right. Curious why this is taking so long to save. Don't really need this open, but yeah. So I think this test will suffice as far as just complexity, and then we'll just change the resolution. I don't think I don't think we need to get too crazy with how we set it up. As far as the scene goes. So if Blender starts loading here at some point, we'll uh, we'll run another one that's simpler. And actually, this one we'll probably tone this one back because um, it doesn't need to take 10 or 12 minutes to run the test. So we'll probably do like 50 frames on this one and see what that does. And then we'll do 50 frames and we'll reduce the resolution by a lot. And we'll just try to stay under 64 gigs of RAM for this heavy one and under 16 for the light one. And then basically, yeah, I'll name the files um, so that they correspond to what they are, and then I will throw them on Patreon like while we're doing this, and that'll be it. Then you guys can download it and test it out. And the goal will be if you just download the file, open it up, and run the simulation, there shouldn't be any other tuning you have to do. Obviously, if you want to play with the scene and just change resolution and stuff, um, then we can report those results just with what you changed. But um, then we'll have kind of a jumping off point at least. All right, Blender, what are you doing here? I mean, even if it was somehow saving all of these files, they're only 40 gigs. It shouldn't take this long. I'm not sure what it's doing here. Just having a nice little Blender crash, I guess. But I think we know what we want to do. So this one was, I'm writing these down on a sticky note just so everyone knows. In case this crashes, we'll just set it back up really fast. 128 resolution. I turned the bubbles on. I didn't change any other settings with the bubbles. I just enabled them. Um, we're gonna run 50 frames and see how that goes for this heavy one. What else did we change? I think there's not a lot else that went into this. So I'm just gonna kill Blender here. Not sure why it was loading so slow anyway. Um, but let's just reopen it and see what we had in the scene. I think I have all the settings. Yeah, see, all the objects are still in there. Okay. Yeah, so we want our effectors, which are the objects in the scene. We want those to be in the water. Otherwise, they didn't do anything. So let's make sure that 50 frames gets us some interaction. Yeah, 50 frames should give us plenty. Sweet. All right. So yeah, let's do that. So we're going to end our simulation at 50 frames instead of 100. I'm going to set this back to the first frame. So now let's save this file as, oh, what should we call these? We'll just call them high and low. Let's just call it something simple. CPU fluid test, and then we'll just call them heavy and light. So for the heavy one, we'll do 50 frames. Let's free the bake here. I'll set that up. I'll save it before I try to bake anything. 128 divisions is probably fine. So we'll try that. So I'll save that. That's probably going to use 30 plus gigs of VRAM or of system RAM. So I'll leave that alone. And then just so we keep our settings consistent, I'll save this now as the other file. So this one is going to be the light file. Now this is the one we have to do some tuning with. So let's pull this over like we had it. And we'll put our task manager up. Okay, now keep in mind, I'm just idling here with Blender open. I'm using almost 12 gigs of RAM. I think I have background stuff open. So if you don't have that problem as much, and I'm streaming, so like OBS is using some, you probably won't have that problem. But we're going to try to keep the total use under 16 for this one. So we're going to still do 50 frames. Let's just knock this resolution down to 64. So we'll cut it in half. And I think let's try that and let's just see what it does. Okay, so that really hasn't added a whole lot of memory use. And it's running really, really fast, actually. So that's only using like not even a gig of RAM. CPU use percentage-wise is kind of similar to the other one, but that got done in 20 seconds. So that's definitely too easy of a test, I think. Yeah, so even the viewport plays back really nice. Looks like our resolution is plenty for our objects to be affected. I don't know if the cylinder is actually getting hit much. That's okay though. And then let's go see what our particles or what our sizes are here. Yeah, so 500 megabytes for the baking files. That's not really that bad. I think everybody can handle half a gig of storage. But we definitely need some additional resolution because that was too fast. There's no reason to run one that's that fast. So let's kind of split the gap here. So let's just try like, I don't know, let's just try like 86 for the resolution and we'll run that again. The nice thing is we can just do this over and over until we're happy with it. So it looks like we've got all the threads working. They're around 50% use. I would say about a gig of extra RAM needed versus what I was idling at. Yeah, all the cores are in use. Yeah, see, now in frame 35 plus, it starts to get heavy, and your memory starts to ramp up, and the baking really slows down quite a lot. Okay, my system is still under 16 gigs of RAM. I think if you're running this and you're having problems, okay, so that took about a minute. If you're running this and having problems with RAM, just disable or close some of your fluff that comes in Windows. Because like obviously a bunch of this stuff I don't need to be open. And Blender itself uses quite a bit of RAM, but yeah, I mean there's a bunch of background garbage that you can disable to make sure this works. But here's what this plays back like. So this one took 1 minute on a 16 thread processor. I don't know if that's heavy enough in my opinion of a scene. But I think you're going to have a problem staying under. So basically what'll happen is if I were to only have 16 gigs of RAM and I start to run this file, if it maxes the RAM out, it's going to significantly slow down the simulation because it has to cycle the data in and out of the RAM more. And just because Windows says that it's using this much RAM, it's not necessarily actually using it. It may just be reserving it. So keep that in mind too, that certain apps will reserve memory even though they're not actually using them. So it's possible that Like when on the heavy scene, when it's saying it's using 32 gigs of RAM, it may not be actually using it. You may have plenty of space left. It's just that it's the hardware gets to reserve RAM, or the software gets to reserve RAM based on, you know, um, how high priority it is. But yeah, so I think for now these are decent tests. Um, I'm still not sure about a minute on this. I think we should make uh, let's try 100 frames. And let's free this bake. Let's do it one more time. So this is the light scene one more time. We're gonna bake it with 100 frames here and see what the situation looks like. We may do something like 60 or 70 instead of 100 too, but I just think we want to make sure that we're getting um, the threads filled up on the CPU more. But the way this looks to me is faster systems with better RAM and better IPC in their CPUs may be enough to beat out a higher core count on like this 5950X. And the other thing I really want to test going forward is what is the effect of the 3D cache that AMD has in their new processors. So I would really, really like to test a 7950X versus the 7950X 3D someday, just to know if maybe like storing all that extra data in the cache would prevent a lot of this loading. Because if that's the case, if some of this stuff can stay in the cores and just continue to run, then you'd have massive speed ups, not just 5 or 10% speed ups, like you see in gaming. Sometimes it doesn't really make a lot of difference. Sometimes it's a fairly good difference. But I think in here, if you could keep all this frame data inside of the um, CPU, you would have absolutely massive speed boost. But I've never seen somebody testing a CPU simulation with 3D cache versus no 3D cache. So that's one I want to do in the future. I just am not about to buy two of those right now to test them. I don't even have a motherboard or RAM for those newer systems yet, so that may be a while, but I'm sure some viewers have that stuff, so they will be able to test it now. But okay. Yeah, so look, it looks like once we get too far past 50 frames, um the memory the memory requirement for this is way too high. So uh, like we're at about frame 85. I don't think we're going to do that. We're not going to extend it for the light variant. It's just too heavy. Um, because you'll see the RAM just continues to go up and up because it has to load bigger and bigger meshes every time. Yep, and it's about done here. So I will free it one more time. We'll save it so that it's preset to 50 frames, and we could probably run like 60, but at some point it's not really going to make a lot of difference. Okay, just about done. 99%. These frames still don't take that long. So that took 220 seconds. So let's free this and let's go to just 60 and run it one more time. I just really don't want to have a super easy one. And there's other settings that we can play with in here. Um I think there's no reason to get too complicated if the RAM size is going to be the limiting factor anyway. But yeah, see, these first frames just go so fast. It just seems silly um, to run it at that short of a test, I guess. All right. Yeah, see, and we're pushing it here. It looks like we're using right at 16 gigs of RAM. But that's probably going to be the case even up to 40 frames of this simulation. Let's go look at processes because, internet browser and some of these other things I could easily get rid of to get back under the 16 gigs. It's going to be really close because now we're more than 1 gig over. But you guys probably won't be streaming and running Blender and all that at the same time, so I think it's just going to be really close. Yeah, so I'm trying to think of another way that we can make this hard to process, but not increase the RAM requirement. I think with fluid simulations, you're probably not gonna be able to do that. I think they're gonna scale together, um, and we don't want to artificially limit the test by just having a high RAM requirement. So let's set this to 50 frames, and people are gonna have to let me know if the scenes work. So if you're limited to 16 gigs of RAM, just run it and see if it works, and then we can publish new versions of the test just to you know just to kind of update it for what people need. So I think for now though I'm gonna save this once. So for now, the light version is going to be 50 frames. All the other settings are the same, but it's going to be 50 frames at 86 for the resolution, and it's going to take plus or minus a minute on a 5950X processor. Um, but I think this one's ready to go. Here's what the file looks like. If I hide the domain, that's all it is. Simple materials, simple objects, not much going on. Um, yeah, so that should be pretty slick. The high detail version. Let's make sure we have that where we want it. Okay, this one is going to be a 128 resolution divisions. Let's make sure our frames are set right. So it's going to be 50 frames. The resolution's way higher, but that's it. That's the only difference. Is more or less the resolution. So, um, and keep in mind you're adding divisions in each direction. So if you double the resolution divisions, you're not doubling the uh, detail, you're doubling it in all directions. So it's 8 times more if you double it because it's 2 times 2 times 2. But yeah, so I will share these files. Let's see what they are. So they're just over a megabyte, 1.11 megabytes per file. So I'll have a post on Patreon here in just a second that shows or that has these, and it's just going to be basically just a blend file on its own. But they'll say CPU fluid test heavy and CPU fluid test light. So I'll post them soon, and then we'll have to decide how to report results and stuff like that. But I think the biggest challenge is going to be like how do you time it? But if you look at this when I bake it, so I'll run this one more time. We can pull up our task manager here just to see what we got going. Yeah, see, I think the light scene is going to be pretty easy to stay under 16 gigs of RAM. I don't think that's going to be an issue. It's only 12 right now, although it is starting to ramp up pretty quick once you get into the higher frames. And everybody's system will vary, but so what you want to do is watch the bottom of Blender. When your bake ends, it'll pull up um, a little box that tells you how long the simulation took. So it's going to be right around here. Okay, so it says fluid bake complete 59.61 seconds. So this test took me about a minute. So, and here is the result. And we can hide our fluid emitter, which is that cube. So you can see the fluid is interacting with the sphere, and closer to the end, it gets deep enough and it splashes so that it interacts with the cylinder as well. But you know, even on this lower resolution frame, this is particularly high detail. Like it already looks really good. So I definitely, you know, I don't have any complaints about the scene. Like I would consider using this for something. It looks good. It looks very realistic detail wise. So even though we're calling this the light test scene, it's not really, you know, it's not really that um, basic of a scene, if you will. So now, out of curiosity, I'm gonna open. I'm gonna open this. This was the like first file, so this is not our named files that I'm gonna share. This is the like first version of it, so it has all of the objects. But what I'm gonna do is I'm gonna test this in Flip Fluids and somehow try to match um, the settings as well as I can, because again, I don't think the settings match up very well. But we're going to take all the physics off of all these objects, and then we're going to use Flip Fluids to rebuild the simulation, because I'm curious to see what will happen with it. So okay, we need overlays on. We don't need X-ray mode anymore. So Flip Fluids created the domain out of the cube. And then this cube here is going to be a inflow. And you know, I don't know if you could really compare the two add-ons all that easy anyway, because I really think the settings are so different, it's going to be hard to compare them. But we're going to try. Okay, so now this floor actually isn't really doing much. I think it's actually just going to go to the bottom of the domain. So I think I'll just kind of move it to make it look okay. All right. So grid resolution. number of grid voxels on the longest side of the domain. So if it's a cube, a perfect cube, the resolution should be number of divisions in each direction. So that should actually line up okay. So now let's bump this up to 128 to match what our heavy scene does, and that looks like it's the same idea. So 128 divisions in each direction, and then I think we have these all set to obstacles, so that should be fine. This one is a fluid inflow. Now all we should have to do, let's take the grid off. Let's go to our settings. We're going to do 50 frames just to match up with the Blender test. And then so if I come down here and flip fluid stats, it'll show us the cache info, so we can see how big our file size is just from there. But that's not going to matter too much. Cache directory, it's going to be within our file here, so that's good to go. I think we're good to try this. So let's save this file. And actually maybe we'll save this as CPU fluid test flip add-on. And then I can share that one too if people want to test flip fluid separately. Some people have it, some people don't. So I don't want to force people to have to get it, and that's why we did our test in Blender. But let's bake this and see what happens. And let's get our task manager up. Okay, so interestingly, I'm not sure if the CPU usage is actually higher or not in Flip Fluids. It looks like there's fewer cores that are like fully utilized, though. There's not the 5 that are being completely used. We are already halfway done with the simulation. So what I'm most curious about with this test is what is the effect of Flip Fluids on the speed. It looks like so far it's already less RAM requirement, but we still have the heaviest frames to go, so I'm not going to get too excited about that yet. But the nice thing is Flip Fluids will tell us how long this bake took, so we don't have to worry about looking for a timer. I'm pretty sure this is already way faster, though, even though it doesn't necessarily look like the CPU's been used that much more. But let's just see what we get. So I'll write this down, and then we'll run our Blender test one more time and just kind of see how they compare. But oh yeah, the usage definitely looks higher now than on the Blender scene. But it's very hard to tell because a lot of the spikes on the graphs are just they're so fast that I don't think they register very much on the summary down here. But 5 frames left. To me it seems like it's already gone faster, but I don't know for sure, so we'll check. Yeah, one thing I've noted already though, the memory usage for Flip Fluids for this heavy version is already significantly less compared to the Blenders. simulator. So this one, the cache file is 650 megabytes, and it took a total of 2 minutes and 54 seconds. I'm just reading that from the cache info under Flip Fluid stats way at the bottom. There's also this frame info, which gives you more detail on each frame, which is kind of cool. But so that's so yeah, 2 minutes and 54 seconds. Let's go back and run the heavy scene in Blender. And I'm actually kind of surprised these converted so well. But now this one is the Blender native fluid simulation. It's 128 resolution divisions. Where is that? I want to show that so you guys can see. Grid display. Oh, it may be on here already. I think it's on here. It's just tiny. There it is. I need to show overlays. Yeah, here's our little tiny cube. I guess Blender doesn't show like the full breakdown. Like it doesn't show the full resolution, but you can see it's that little tiny cube. So let's run this now. So it should be the same resolution. It's 50 frames. All of the other settings, they should be close. You know, the only thing I can say is I haven't gone through all the settings to try to tie them together, because that's kind of hard to do. But let's just see what we get when we run this, and maybe we'll make a conclusion, maybe we won't. So the first thing I want everyone to note is that the memory usage will be quite a bit higher for the Blender simulation than it will be for the Flip Fluids one. So on the Flip Fluids one, I think we didn't get past 16 gigs of system RAM used. And I believe on this test, we probably will get quite a bit higher. But we'll see. Because if we don't, then that's a good sign. And maybe our softwares were just reserving the RAM. CG Fiction, hello. Welcome to the stream. 66.8 seconds. 1 minute and basically 1 minute and 7 seconds. Okay, okay. So this test actually ran faster than the Flip Fluids one. It's really hard to compare these. Let's see what frame 50 looks like on this one. Wait a minute. How come that didn't run? Looks like it didn't bake anything. CPU fluids test heavy. Well, that would explain why it only took a minute, because it didn't seem to do anything. Yeah, welcome to the stream. We're just playing around with some fluid simulation here, trying to get a standard benchmark scene set up for CPU testing in Blender. It looks like somehow I broke the... You know what? We need to make sure we got our files the right way. So the cache goes into the the file with the Blender file in it, so that should be fine. What else did we change? I don't think we changed anything else. Let's try to bake it one more time. Definitely seems like it's running too fast though. Because before it was really bogging down a lot more than that. Yep, when Blender is baking, it locks the user interface, so I can't scroll around in Blender to see what my settings are. But yeah, I'm a little suspicious of this file at the moment because it didn't generate a fluid surface. So we need to figure out what exactly is going on with that. I think it's maybe working this time. The CPU and RAM use are starting to go up a lot, like I would expect them to. But yeah, the first time we ran this one, it just kind of flew through the frames, and that didn't make any sense at all. I may have just had something disabled in the scene, I guess. Yep, so now my system has passed 16 gigs of RAM used. So this being the heavy test is intended for beefy machines, basically. CPU use looks like I expect something like 50%, according to the summary. And yeah, now once we get to these heavy frames, our RAM is just going to start to skyrocket, which kind of makes sense because if you think about how the fluid sim works, it uses every last frame plus some physics rules to generate the new frame. And so it's got to store the last frame in the computer to compare to, basically. So, if you have um, a large scene with very, very heavy frames, a lot of data, you're going to have to store that. Your RAM use is going to increase as you run your benchmark test or as you run your simulation. So now we're getting up into the closer to 20 gigs of RAM use. So the heavy scene's definitely going to be better for beefy machines. I think you could still run it just fine on machines with less than 16 gigs of RAM or with 16 or less. Um, you're just going to have some significant throttling because of the CPU having to call the memory that is full. So you're going to have some back and forth that is going to cause a lot of issues. But the RAM may or may not be reserved by software and not in use too. So Windows tends to prioritize things differently, and once your application that's currently running needs the RAM, it'll free it up if it can. But okay, this one's almost done. Just 2 frames left. And we're going to watch for that timer that pops up at the bottom. All right, just one frame. We're on the last one now. Let's see what we get. 255 seconds. So 3 minutes and 15 seconds, right? No, 4 minutes and 15 seconds. 4:15. So that's a minute and almost a minute, well, a minute 21 seconds slower than the Flip Fluids version of this, which we don't know if they convert well or not. But The bake size is 4.5 gigabytes. Whereas the flip version of this was 650 megabytes. So the flip was a smaller cache, used less RAM, and was faster. Just for reference. So, but yeah, I mean, here's what it looks like. 128 resolution divisions. Let's turn the overlays off here. Let's pause this real quick, and we'll turn our fluid emitter and our domain object has to stay on, I guess, because that's the fluid, but yeah, here's the level of detail we have on here, which honestly is pretty good. It's very, very big resolution setting, so that doesn't look half bad at all. So what we'll do is I will free this cache and then save this file, and then I am going to throw these two files, the light and the heavy versions, up on the Patreon account. Again, you don't have to pay anything to get them. They'll be free on there. That's the only way I have to share files conveniently. So you go there and you'll see a post with these files. You can just download them from the post. I think that's a good, safe, neutral way for us to share files, at least from me to you guys, because then I don't have to like share Google links or anything like that. But yeah, when I get monetized in the future, I'll be able to share files for free on YouTube, I think, through like the storefront. So that's what I'll do. But yeah, so watch for a post on the Patreon page. I do have a link to the Patreon in the description, so you can go there and watch for the post. But I'm gonna end the stream here and go post that right away. So within 5 or 10 minutes, it should be up, and we can start to share some benchmark results. So all you have to do is open the file, set up your file path basically, and hit bake all. So you come to the physics tab here on the side of Blender, select your domain. So go to physics tab and then come all the way down here to where it says cache. And then you can just say bake all. It's going to default to the // which is the destination where your file is. So if you ever see that, the directory is just pointed to the same place your file saved. So you'll have to save this on your system somewhere, and then it'll give it a place to store the cache, and then you hit bake. It'll start to run it. When it gets done, record the time. It'll pop up down here on Blender, or you can record it manually, just with a timer. And then when you report your results, just report them with what your processor is, what your RAM speed is, and RAM size is probably good. And then if you change any other settings just for fun, definitely report those too, because that would throw the results off. But yeah, feel free to do whatever you want with the scene and test it how you want. And let's get some CPU benchmarks going. So, but yeah, anyway, thanks for watching. I think this is a good first scene to test out and see, you know, what we need to do. Maybe we can improve it and make a new version of these in the future, but I think for now this is going to be really good. So let's call it good for now. I will post that in just a few minutes, and I will talk to you guys again soon. Thanks for watching, and let me know what you think. So yeah, send me those results in the comments. Have a good one, guys. See ya.